Hi everyone and welcome to this Wolseley Live session with Wolseley Underfloor Heating. We're here with David, who's Category Manager at Wolseley. David, thanks for joining us. How are you?
I'm very well, thank you. How are you?
Yeah, brilliant. Thanks for joining us, everyone. A bit of housekeeping before we start. If you have any questions as we go through the presentations, there's a comment box to the right. If you can use that, and there's an ask a question button underneath. That's more like a LinkedIn, Facebook style comment and answer section. So if you have any questions as we go, drop them in there and we can get the answers to you through the text. David, thanks for joining us. Can we have a bit about your background and role at Wolseley, please?
Yeah, good afternoon, everyone, and welcome to today's webinar on Wolseley Underfloor Heating. My name is David Van Davenvorder. I'm the Category Manager at Wolseley, specifically for the local plumbing and heating installer. And today, with some help from our preferred suppliers, we'll be rediscovering underfloor heating for both new and existing installers. Yeah, so in today's webinar, we'll be covering firstly an introduction to the Wolseley underfloor heating service. Moving on to an introduction to underfloor heating with our friends at John Guest Underfloor. Then we'll be hearing from Jewel on renewables, legislations, and hybrid underfloor heating systems. After that, we'll be taking a look at how an underfloor heating system is designed and the key influences surrounding this, with help from the supplier Myson. And lastly, we'll be finishing the session with a Q&A session. So, what is Wolseley Underfloor Heating? So, Wolseley Underfloor Heating was created to offer a one-stop specialist shop for all underfloor heating inquiries. Our service is centred around an easy-to-use quotation form, taking about 5 minutes to fill out, and returning the quotes back to you in less than 24 hours. Every system we quote for offers a robust product warranty and full system indemnity. A full CAD design is supplied with every order, and you can count on us to offer a designated resource offering technical and on-site support. The controls on offer range from traditional to smart and touchscreen technologies. So if you're interested, visit www.wolseley.co.uk/UFH to request a quote today, or contact us via the email in the website. I will now hand over to Ollie from John Guest for an introduction to underfloor heating.
Hello and welcome to Underfloor Heating Explained, part of the Wolseley Installer Live event. In today's session, we're going to talk through a brief underfloor heating market overview, reasons why you would install an underfloor heating system, how underfloor heating works, what are the key components you need to install an underfloor heating system, heating controls, suitable floor finishes, screeded floor solutions, timber floor solutions, single room packs and where to use them, and further information on the next steps for your project. The UK underfloor heating market continues to be one of the fastest growing sectors of the UK heating industry, accounting for approximately 8% share by value in 2019. The underfloor heating market has an estimated value of around 171 million, representing a steady growth of 3% compared to the previous year. This market is broadly classified into two product types: water-based underfloor heating systems and electric underfloor heating systems. With the implementation of future home standards, market proposals for underfloor heating systems in the UK remain positive. Water-based systems are particularly compatible with low-carbon home heating solutions such as heat pumps. The performance of the UK underfloor heating market in the last 5 years has been positive, reflecting buoyant activity with some sectors of the non-residential construction industry and relative stability in the residential house building and renovation. The increasing focus on energy efficiency and the environment has supported demand for underfloor heating systems. It is estimated that water-based underfloor heating is around 25% more efficient than radiators when used with a condensing boiler, and up to 40% more efficient when running from a heat pump. Greater uptake of heat pumps in the renewables sector is also thought to have contributed towards growth in the market, and they will have an increasingly significant role in meeting the 2050 carbon net zero target. In 2019, the domestic underfloor heating sector was worth an estimated 113 million, or around 66% of the overall market value. This includes activity by house builders, the self-build market, and refurbishment projects in residential homes. The water-based underfloor heating sector was worth an estimated 111 million, with electric underfloor heating systems accounting for around 60 million. Many people think of underfloor heating as a posh form of heating. In reality, it's a more human form of heating, working with the physiology of the human body. We are predators, and all of our senses, smell, taste and hearing, are on our head and cannot be covered if we are to survive. Even in extreme cold, we can have our face uncovered. Warm feet and a cool head is the way that nature designed us. Underfloor heating, unlike radiators that work with high temperature boilers but won't work well with low temperature air source heat pumps or ground source heat pumps, underfloor heating will work well with high and low temperature heat units. Underfloor heating systems have much more sophisticated control methodology. Using programmable thermostats in every room is the ability to turn on the boiler on and off for every room in the house. Unlike radiator systems that rely on one central thermostat that turns on every room in the home. Underfloor heating is compatible with conventional and renewable heat sources that reduce environmental impact and cut fuel bills, including air and ground source heat pumps and solar panels. It's designed to work with low water temperatures and can reduce energy consumption and heating costs by up to 20%. Underfloor heating also creates more living space. By removing bulky and unsightly radiators, it will free up wall space and give freedom for interior design. It creates a healthy living space with less moisture and lower air movement and may help reduce dust allergens. Plus, with no hot radiators and sharp edges, it creates a safer space. Think of a bonfire. You can stand in front of a bonfire and the radiated heat will be felt on your face and body. However, your feet and back can be freezing cold. This is an extreme example of radiator heating. Underfloor heating, however, warms your feet, and radiated heat warms your body from every angle. How does underfloor heating work? Intelligent room thermostats activate the correct zone to heat on the manifold. The control pack pumps warm water through the circuit of pipes beneath the finished floor. Once the desired temperature is reached, the zone will switch off. If the air temperature in the room drops, the thermostat will reactivate the heating process. Key components to an underfloor heating system. When buying a car, there is a huge choice of different types available. Each model will have benefits and drawbacks, mixing the purchase cost, power, fuel economy, gearbox type, technology and number of seats, etc. All these features need to be carefully considered to achieve the best package. Underfloor heating systems are exactly the same. Careful consideration needs to be made when combining the components needed to make an individual system. Considerations such as heat needed for the project, number of rooms to be heated, the heat source, the control type, and the floor construction. In order to achieve the correct mix, a comprehensive basket of components needs to be available to the installer. Heating controls come in various types: simple to use dial thermostats, digital thermostats, programmable thermostats, 230 volt thermostats that we can connected to the mains, battery thermostats for simple and retrofit solutions, and internet-enabled smart thermostats. All these types have features that appeal to different customers. Some control packages also have the ability to combine the control of underfloor heating, radiators, and hot water systems in one package. Suitable floor finishes for use with underfloor heating systems. Some floor finishes offer better thermal conductivity than others, and therefore can impact systems' performance. While underfloor heating can work with any type of floor covering, some such as wood and vinyl need extra consideration to prevent excess temperature. Most ceramic and stone floor finishes have a low thermal resistance. The hard surface quickly and effectively transfers heat, making it an ideal partner for underfloor heating. Vinyl and linoleum flooring offers low resistance to heat due to its thin layer. Most types of vinyl and linoleum are suitable for use with underfloor heating, but the temperature should not exceed 26 degrees. Due to good heat transfer properties, timber floors work well with underfloor heating, especially engineered timber. Temperatures should not exceed 27 degrees and advice should be sought from your supplier. Carpets provide the highest heat resistance. Make sure the underlay is suitable for use with underfloor heating and the combined carpet and underlay TOG value is less than 2.5. The higher the combined TOG value, the lower the heat output. Pipe fixing systems for screeded floor solutions. In the UK, there is an overwhelming variety of construction methods. This applies to floor types as well. Concrete and screed, joists and floorboards, block and beam, manufactured joists, floors under construction and existing floors. Some buildings combine different types in one construction. Many of these floor types present different challenges to the underfloor heating installer. Underfloor heating systems have to be able to jigsaw into these different floors in order to present viable solutions for the installer. The vast majority of underfloor heating systems are installed in solid floor systems. Staple, mounting rail and castellated mats are the typical choices for this application. Existing floor solutions. Joisted floors present different challenges. Underfloor heating can be installed either underneath the floor or above the floor. Under the floor installation is often chosen as it has no effect on the floor height. It can be difficult in existing properties. Underfloor heating fitted above existing floors have the advantage of easier installations and in most cases higher performance. Spreader plates from above will be used on traditional wooden joist and they sit between the top of the joist and the floor covering. Spreader plates from below are typically used for installing into an existing building where you don't want to lift the floor up or where the building has engineered joists. Spreader plates from below sit within the joist span but don't interfere with the existing floor above. Overfit is a typical solution for putting in a sandwich layer over an existing floor where it is not possible to access the floor joist or cut into the floor. Aluminium spreader plates for below flooring and overfit boards for above flooring solutions are the usual choice. Single room packs. These are suitable for single rooms including conservatories, bathrooms, kitchens and extensions up to 30 square metres. There is everything in one simple pack. Simple push-to-fit connections and flexible pipe, ready to plug in pre-assembled control unit and pump, user-friendly programmable controls, whether standalone or connecting to an existing radiator network. Once you have decided on using one of the underfloor heating systems we have talked about today, you will see Wolseley provide a 24-hour quotation tool through their website or extensive branch network. A further range of how-to and technical data videos are available on www.johnguest.com. Simply connect to the website or type in the link for more details and support options available.
Thanks very much for that, Ollie. I'd now like to hand over to Paul at Joule, who will talk to you more about underfloor heating and renewables.
Hello, my name is Paul Stewart and I'm the Renewables Sales Manager for Joule UK. Wolseley Underfloor and Renewables. What products can we supply for your projects? Underfloor heating is ideally suited to a renewable heating system, so to accompany this, we have a wide range of renewable systems available. Underfloor heating. Underfloor fixing methods for both ground and upper floor levels and systems to support all project types and applications. Air source heat pumps. In conjunction with underfloor heating, air source heat pumps are a renewable energy source that has a low carbon footprint and is cost effective. Aluminium radiators. Not only aesthetically pleasing, our designer radiators have a high heat transfer and are ideal for air source heat pump applications. Solar thermal. A solar thermal heating system generates heat by using solar radiation to heat the hot water in your property. It can work with underfloor heating and air source heat pumps and is also cost effective. Why choose renewables? The Future Homes Directive 2025 This directive puts forward a notional building design which sets out areas where improvements are made. Due to the implementation of new Part L and Part F, the minimum carbon reduction required is 30%. It is proposed that the 2025 Future Homes Directive will require a 70 to 80% reduction. This reduction can be achieved by implementing fabric improvements and/or the use of low-carbon technologies, such as heat pumps. By fitting a heat pump now, it is ensured that the installation is Future Homes ready. Heat pumps operate more efficiently at lower flow temperatures, so underfloor heating is the perfect partner. How does a heat pump work? An air source heat pump is classed as a renewable heating system as it does not produce any CO2 emissions. It runs off electric, but it takes its heat from the outside air and transfers this to your heating and hot water. The system produces a low temperature heating, so heat emitters such as radiators and underfloor heating must be sized with this in mind. When designed correctly, an air source heat pump can cover 100% of your heating and hot water load and needs no backup boiler. Why choose a heat pump? A typical air source heat pump has a COP, or coefficient of performance, of around 3.2. This means it generates 3 times more heat than its energy input, thus making the system over 300% efficient. A seasonal COP, or SCOP, is adjusted to account for the varying outdoor temperatures in the different seasons. Thanks to an outstanding SCOP, heat pumps are efficient all year round and can still extract heat from the air in very cold external temperatures. Solar thermal panels are another way of heating your hot water using renewables. These panels use the solar radiation created by the sun to generate heat. This heat is then transferred to your hot water cylinder via an additional coil. Solar thermal panels can be integrated into boiler systems, and their inclusion reduces the load on the existing system, resulting in a reduction of your CO2 emissions and your fuel bills. Solar thermal panels can also be integrated with an air source heat pump system, increasing its efficiency even more. The inclusion of radiators can work to boost the effectiveness of an underfloor heating design. A popular choice are aluminium radiators, which offer a stylish alternative to steel. With a high quality, modern powder-coated white finish, these radiators provide a higher heat output at lower flow temperatures and are ideal for air source heat pump systems. They come available in a range of horizontal and vertical sizes. Aluminium radiators can also be used with a renewable air source system. Aluminium radiates heat better at the lower temperatures a heat pump provides, meaning they will produce a higher heat output than standard steel radiators. The type of hot water cylinder must be considered when choosing your system. A standard indirect cylinder has a coil suitable for a high temperature gas or oil boiler. When using a low temperature heat pump, a high gain cylinder must be used. This has a bigger coil which can transfer the lower flow temperatures better to your domestic hot water. When using a solar thermal system, a twin coil cylinder is required. These are available in standard indirect and high gain models and have a secondary coil for the heat generated by the thermal panels. Finally, cylinders with integral buffer tanks are also available. These are for use with renewable systems and are used to increase the system volume and the efficiency. Things to think about when selling renewable products. If you're being asked to quote for an air source heat pump on a new build property, does your customer also require underfloor heating, radiators or solar thermal? Wolseley can assist with this. The same applies for a renovated property. If supplying an air source heat pump, the customer may need to upgrade their underfloor heating and radiators. Again, Wolseley can assist with this. Let your local branch know if you have a project you think could benefit from renewables. Wolseley Underfloor Heating will work with our suppliers and new installers to quote underfloor and renewable systems which meet the requirement of the 2025 directive. Radiators can be added to any design upon request.
Brilliant. Thanks for that, Paul. And now I'd like to hand over to Kevin at Myson, who talk a bit more about the underfloor heating design and some of the system influences that need to be considered.
Hello and welcome. My name's Kevin Taylor, National Sales Manager for Myson Underfloor Systems. Thanks for joining us today to consider underfloor design, recommended practice and system influences. And in the interest of clarity, I'm the strange looking guy down there in the corner. Now, throughout the last decade, underfloor systems have greatly increased in popularity. Modern systems offering greater flexibility and control. But actually these systems stem back to Roman times or even earlier than that, about 2000 years ago. And what these civilizations discovered was this form of heating is incredibly efficient. Now there's lots of different types of systems on the market, but the basic principle is exactly the same: to warm the floor and create a low temperature heat source with a large surface area. So in order to do that effectively and efficiently, there are a number of factors we need to consider, specifically regarding design. So these things can influence the system: pipe spacings, quantity of pipe in the floor, the conductivity and depth of screed, the diameter of pipe that we're using, the floor coverings, flow temperature into the system, the room temperatures we're designing to, the control philosophy, insulation levels, and air changes. Quite a lot to take in, but we're going to talk about some of these factors. We're going to consider what we look at when producing a design. We'll look at some examples, we'll understand current guidelines, and hopefully that will give you an appreciation. And we're going to do all this in just a few minutes. First and foremost, let's think about our heat provider, because this affects the flow temperature into the system. Using a renewable source of energy, like an air source heat pump or a ground source heat pump, may mean that we need tighter centres than, say, a traditional boiler. But we should appreciate what those temperatures are, and we should also appreciate what the temperature drop across the system should be, what we're designing to. A little bit of misconception when it comes to design. So again, in the interest of clarity, we work to the relevant standards, and they're British Standard EN 1264 parts 1 to 4. Now, don't panic. I'm not going to go into every single standard and what it means, but in general, we'll work to the following guidelines. We're looking to heat rooms to 21 degrees C if they're occupied, 22 degrees C in bathrooms, and 18 degrees C in bedrooms. And we're looking to achieve those temperatures at -3 outside in England and Wales, and -5 in Scotland. Now we can't just blast as much heat into a floor as we want, because there are also maximum permissible floor temperatures that we must adhere to. Occupied living areas, that's 29 degrees C, bathrooms 33 degrees C, and peripheral areas or border circuits 35. Now some of your customers may use a floor covering that doesn't want to accept some of the higher temperatures here, so typically woods and vinyl, that kind of thing. And in these instances, we can use sensors to limit them, usually about 27 degrees. Now, when you look at a design, generally you'll see uniform pipe spacings, and that's been calculated to allow for the heat loss of the room. But as installers, we must use common sense, it must prevail at all times. So it makes absolute sense to tighten the sensors across areas of very high heat loss. For example, a highly glazed outside wall. We can widen them then in the centre of the room because we're not losing heat there. Same quantity of pipe, but will have a positive effect on performance. Okay, well at this stage, let's have a look at the two different types of circuit that are laid. We've got the spiral method on the left, or sometimes called the reverse snail pattern, and we have the serpentine method, or the S pattern, on the right. Either of these patterns are absolutely fine. We like to promote the spiral pattern where possible because it does help with even heat distribution. So uniform expansions of screeds and that kind of a thing. If whichever pattern you're going to lay, can you please make sure that the flow pipe runs around the perimeter of the room, as you can see from the pictures. Another really important factor, of course, is where we're going to put the manifold. Well, the rules and regulations say manifolds should be sited centrally. And this is to minimise the length of interconnecting services. So please don't pop your manifold in the garage under your boiler on one side of the house. It's not really a good idea. But there may be instances where these long service lengths of pipework are unavoidable. Possibly things like barn conversions or sort of very long buildings, L-shaped buildings, that kind of thing. And in those instances, we must insulate or route this pipework through conduit, and that reduces transmission losses. And what about insulation? Well, insulation is always recommended. It ensures that as much heat as possible goes upwards into the house or building, and as little heat as possible is lost in downwards. Resistance below the pipe should therefore be much greater than that above. A general rule of thumb here is we would expect the resistance below the pipe to be 10 times greater than the resistance above. What about designs with high ceilings? Well, we get asked about this quite often, and underfloor heating, it doesn't produce the same convective gradients as radiator heating. Therefore, the additional factors for rooms with high ceilings can generally be ignored. A little bit of consideration though should be given if you're using any kind of mechanical ventilation at a high level, because this can promote convection. Underfloor is radiant heat. What about control? And what do the standards say? Each room should have its own thermostat, sensor or programmable thermostat. This is taken from the standard, by the way. That's each room, not each zone. It does go on to say where two adjacent rooms have similar function, for example, a kitchen utility, it may be appropriate for both rooms to share a single temperature control. Well, we often see hallways and WCs being requested to have the same point of control, and whilst they may be two adjacent rooms, I don't think they have a similar function. Well, certainly not in my house. So as we sort of get to the end part of this presentation, I did want to spend a little bit of time on floor coverings because they make a huge difference to the design and to the output of a system. So in this particular example, lots of numbers and figures here, but we'll look at concentrate on the ones in the red boxes. This is on a system that's running at 50-degree flow, 43-degree return. And we're looking to achieve a room temperature of 20 degrees C. On the right-hand side, you can see the surface resistance. And you can then see the difference between the first box and the very last box. Working on all the same conditions, all we've done here is change the floor covering. So we've gone from 128 watts a square metre for a floor with no resistance, so a bare floor or ceramic tiles or stone. And as we start to add resistance onto the floor, you can see how that drops down to an area where you've got maybe thickish carpet and timber at a TOG value of 1.5, and that's 69 watts a square metre, almost half the output. So it's important we know that. A lot of the time when we come to do design, the floor coverings haven't been decided, we might not know what they are, in which case we would normally look to design to worst case scenario. And you know, if you think about it, how many times have you seen a nice tiled floor where somebody's then put a nice rug on it to sit a table or something along those lines? So it's not rocket science, is it? Well, no, it's not, but it is a science. Designs should carry professional indemnities, and they should be insurance backed and guaranteed, because the outputs, the pipe lengths, the system temperatures, the flow rates, the resistance ratings, all of the above will be taken into consideration to produce an accurate and efficient design. So why take the risk? Get the design produced professionally. And with that, I'm going to hand you over to our design manager here at Myson, who's a gentleman called Craig Ord. He'll go through the final stage of this presentation, look at a couple of designs in detail and the design process. I will be available afterwards for questions. So I look forward to catching up with you then. Thanks for your time.
Thanks, Kevin. So I'm just going to talk a little bit about what we need in terms of information for design and quotations. So on this first slide here, you can see what we ideally need. There's a couple of main things: floor plans, which ideally CAD plans, so we can have them to scale. If we do go and produce a design, then this makes it very easy for us to import into our system, and we can ensure we'll get the most accurate result from that. If they're not CAD plans, they are hand-drawn plans, but they are scaled, then that's also fine as long as they're a scale and we can take that into our system. That's fine. We also like preferred manifold positions. So as you can see there in the drawing, just on the right hand side, there's a couple of manifold positions on that drawing, and these are both manifold positions that have been preferred by the customer. There's a few, or there's one there at the top which is ideally not in the most optimal place, and really if the option was ours, we would move it into this cupboard, but you know, that's what the customer preferred, so that's what we went with. But anything, even suggestions on manifold positions, is ideal to have. Then if there's anything which we need to change, we can speak to the customer about that. But good positions on manifolds need to be central, and this reduces any unnecessary transitional pipe work, and overall gives a better performance of the system. Next thing we need to know is floor constructions and floor finishes. So we need to know whether you are doing solid floor with concrete, or with concrete beams and screed or concrete over the top. Also, whether it's going to be a joisted floor, what kind of joist that's going to be. That can affect the system also. Floor finishes is very important as well. So tiles, carpet, stone, these are very, very good finishes. Things which we need to take into a little bit more account are things like vinyls, laminates and solid timbers. We'll often need to have a floor limit on the temperature for those, which is governed by the manufacturer, and in those cases we will more than likely, if not always, need to supply a floor sensor, so we can ensure that the floor doesn't reach over those temperatures which have been specified by the floor manufacturer. And also we need to know what the heat source is, so whether it's going to be boiler, it's going to be SOC pump, ground source heat pump, these kind of things. We need to know what that heat source is going to be, and we need to know what the flow return temperatures are also going to be. On the next slide, we have a copy of the Wolseley underfloor quotation tool. So this is very useful and takes majority of the work away from people like yourselves. So it's really, really easy. I've just put a couple of screenshots of the actual tool up there. So on the first screenshot, you can see it's quotation request, and you put in all the relevant details, and there's a couple of bits of information you can add as you move down. Second slide there, project budget. So you know what your expected budget is going to be for this portion of the project. You can also put a name and a reference in there, which is extremely handy for referencing afterwards. As you see on the third slide, a little bit about the heat source, as we just discussed before, whether that's going to be air source heat pump, boiler, biomass, you know, whatever it may be. We can put it in there, and if you've got heat pump, there's a little bit there for flow and return temperature as well to specify. That's useful in any eventuality for us to know what you plan on working to. And also the next one down there is the floor construction. So this applies to all floors. There's a section there which shows basement, but this applies to all floors where you can put in individual floors. So the basement will more likely be a solid floor, but if you go to a ground and a first above that, there may be joisted floors, they may be solid, they may be block and beam, this sort of thing, and you can always add that in there. Joist directions as well is always incredibly important. Other things which I've not shown there, but you can include there, are a note for system type. So whether you want to go clip rail, tack and nail plates, preform plate, anything like that can all be requested as well. As we discussed before, manifold locations are very, very important, so that needs to be in there as well, and we do allow an option for that. And then also there's another area where you can attach drawings, so any CAD plans which you do have, any drawings which you've created by hand which are scaled, and then you can scan them and add them on there. That's fantastic. Anything that is really great to have, and it's all handled by this quotation tool. So you know, you can have a quick look online and pick up that tool and enter all your quotations there. And that's it from me. Thank you very much.
Perfect. That just about rounds off our session. So David, for people who are watching this now, how do they get more information about Wolseley Underfloor Heating?
So best place to start would be to visit our website, which is www.wolseley.co.uk/UFH, or alternatively, feel free to send us an email. It's ufh@wolseley.co.uk, and we'll be sure to respond to you as soon as we can.
Perfect. We'll drop those links in the chat box there. That rounds off the session. Thank you everyone much for joining us. Thank you, David, for the time, and thank you to the suppliers. Don't forget to check out our Crowdcast page and installeronline.co.uk. You can see all of the Wolseley live events happening this week. You can sign up for the ones coming up, and you can watch everything on demand. This one will be available to watch on demand as well, so you can share the link around to any colleagues or friends that may have missed it. Thank you everyone for joining us, and thank you, David.
Thank you.